Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. We are now at question 5 of the CSEC Maths January 2013 exam video solution. And this question gives us a scale drawing of a playground showing the north direction and a line RT representing the distance between 2 points R and T on the playground. The scale of the drawing is 1 centimeter to 30 meters. That means 1 centimeter on the drawing represents 30 meters on the playground. And here we are shown the north direction. So we know this question has to do with bearings. And the first part of this question is asking us to measure and state in centimeters the length of RT on the drawing. So basically, we want to use our ruler and measure the length of RT on the drawing. So we have to position our ruler carefully. This represents our ruler, and we ensure that we have the 0 mark at R, and then we can read off from the ruler the distance from R to T. Right, so we carefully position the ruler such that we can measure the length of this line on the drawing carefully. And based on my drawing, I am seeing a distance or a length of 5.8 centimeters, and therefore the length of RT on my drawing is 5.8 centimeters. And so we can write that RT is 5.8 centimeters on the drawing. Now part 2 is asking us to measure and state in degrees the bearing of T from R. That is, we want the bearing of T from R from this drawing. Now the bearing of T from R is the clockwise angle from the north line at the from position, which is R in this case, to the line joining R to T. Right? So the bearing of T from R, R is the from position, and so the bearing is measured at the from position clockwise from the north line at the from position, which is R, to the line joining R to T. And therefore the bearing of T from R would be this angle shown here from the north line at R, which is the from position, to the line, the clockwise angle from the north line to the line joining R to T. That angle is the bearing of T from R. And so we need to bring in our protractor, and this represents our protractor, and it has to be placed properly and carefully so that we can measure this angle carefully. And what we do is ensure that the origin or the center of the protractor is at the intersection of this north line and the line joining R to T. That's the vertex of the angle that we're measuring. And we ensure that the baseline in this case would be exactly on the north line, passing through 0 on the baseline, and we measure the angle from 0 upward to the line from R to T, from 0 on the protractor up to the line RT, and we measure this angle on the protractor. And based on my measurement, I am getting an angle of 65 degrees, and therefore the bearing of T from R is 0.65 degrees. And we can go ahead and show that the bearing of T from R is 0.65 degrees. You place a 0 in front here because bearings must be expressed with 3 digits. Hence we put the 0 in front, the 65. In any case, the bearing angle is 65 degrees, and this is how we write the bearing of T from R is 0.65 degrees. Now, part 3 of this question is asking us to calculate the actual distance in meters of RT on the playground. Now what we have is that RT on the drawing is 5.8 centimeters, and we are using a scale of 1 centimeter to 30 meters, and therefore the distance of RT on the ground is simply obtained by multiplying this 5.8 centimeters on the map by 30 to get the distance that RT is on the playground. And the result of this calculation is 174, and therefore the distance of RT on the playground is 174 meters. Let's go down now to part B. Now part B tells us of another point on the playground, point M, which is 300 meters from R. Point M is 300 meters from R, and it's on a bearing of 120 degrees from R. And therefore, 120 degrees from R again is the from position, and the 120 degrees must be measured clockwise from this north line at R, and 120 degrees will take us somewhere down here, because here between these two lines the angle will be 90 degrees, and so we have to go 30 more degrees under this line to find 120 degrees. And so the bearing we are looking for would be somewhere around here, and so M would be on a line somewhere down here. M would be somewhere out here, and the distance from R to M on the playground is 300 meters. Now part 1 is asking us for the length of RM on the drawing. We know it's 300 meters on the playground, and using this scale of 1 centimeter on the drawing representing 30 meters on the playground, we simply need to divide this 300 meters on the playground to know what the distance is on the drawing. And this is the calculation. 1 centimeter on the drawing is 30 meters on the ground, and so if we have 300 meters on the ground, we have to divide 300 by 30 to get the length of the line RM on the drawing, and that result is 10 centimeters, and therefore the length of RM on the drawing is 10 centimeters. Now part 2 and part 3 of this question wants us to do some constructions. First, we are required to construct the position of M on the drawing. On this drawing, we are required to construct the position of M, bearing in mind that the length of RM on the drawing is 10 centimeters and the bearing from R is 120 degrees. We need to do a construction for that. And then part 3 wants us to show that 120 degree bearing of M from R on the scaled drawing. So if we want the bearing to be 120 degrees around here, the angle from the north line around to the line joining R to M, just imagine RM being out here, then what it means is that the angle between this line southwards and the line RM would be 60 degrees. If the angle around here is 120 degrees, then the angle between this line and RM would be 60 degrees, because the total angle on this line would have to be 180 degrees. And therefore, if we can construct 60 degrees from this line this way, then we would have found the line RM, and then all we would need to do is measure a distance of 10 centimeters to find M. So let's proceed by constructing a 60 degree angle down here from this point R. And to do that, we simply from this point R construct an arc with a compass right here. With R as a center, we construct an arc here. Then we move the point of the compass to this point, and without changing the angle of the compass and the center being here, we cross this arc with a second arc, and that's the second arc right here. Now the straight line from R through the intersection of these two arcs will make an angle of 60 degrees with this line, and all we need to do is bring our ruler in and position it carefully through the intersection and measure 10 centimeters on the ruler, so we can draw our line RM, and M will therefore be at this point. And this is it. That's our line RM, and this is our point RM. And now we have constructed a 60 degree angle here such that the bearing from the north line here to the line RM will be 120 degrees. And as I said, that was obtained by constructing a 60 degree angle here. And the measure of this line now RM on the drawing is 10 centimeters. And so now we can move the ruler out the way and show that angle 60 degrees. So since this angle is 60 degrees, we know this length is now 10 centimeters. And so the bearing angle from the north line at R to the line joining R to M, we can show that angle, that's the bearing angle, and that angle is 120 degrees. So that 120 degrees is the bearing of M from R. And that is the end of this question, and we'll do question 6, our next question, in the next video. See you then. You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.